Okay, let's talk about completing the square. This time when the leading coefficient isn't 1. So I have a term in front of the x squared. Before we do this, though, we need to talk about factoring. So remember, factoring is just reverse distribution, where distribution is just multiplication. Here I have a 3 times x minus 1, so it's a 3 times x, and then plus a 3 times negative 1, and then 3 times negative 1 is just negative 3. So when you when you do distribution, you just do multiplying. So multiply for distribution. That's the deal. Well, what if I started with 3x minus 3? Clearly, 3x minus 3 can be factored into 3 times x minus 1. But the question is, how do we do it? So realize that they both have a common 3. So I'm going to pull that out. And since it's reverse distribution, instead of multiplying, I'm going to divide. So whatever I actually pull out, I'll divide each piece by that factor. Right? So 3x divided by 3 is x. And 3 divided by 3 is 1. So that's how I get 3 times x minus 1. All right. So distribution is multiplication, but factoring is division. All right. Remember, it's reverse distribution, so it needs to be the reverse of multiplication. It needs to be division. All right. So let's factor 2x squared plus 6x. Well, notice that they both have a 2 in common, so I'm going to pull out a 2. So when I pull out a 2, I'll divide each term by 2. So 2x squared divided by 2 is just x squared. 6x divided by 2 is 3x. So I can factor out a 2 and make this 2 times x squared plus 3x. Well, if factoring is reverse distribution, well, we ought to be able to do distribution to check. So let's multiply the 2 back through and see if we get what we started with. Then you see we get 2x squared plus 6x. So this worked. It was a good check. All right. Okay, so you want to stop the classwork and stop this video and do classwork problems 1, 3, 6, and 8. Okay, so now that we know kind of what factoring is all about, let's do, a little review of factoring. Let's do completing the square. So again, the leading coefficient has a square. The leading coefficient on the x squared is a number. It's not just a 1. So if it was a 1, right, we did this before. Let's just recall. Right? If it's a 1, then to make this a perfect square, I need half of this term. So half of 2 is 1. And then I'll need to add that squared. So I'll need to add a 1 squared. And then I'll also need to subtract off the same number I added so that I don't change the expression. Remember, this is our clever adding of 0. So when I add 0, I don't actually change what the expression is. I just change what it looks like. Okay, and then x squared plus 2x plus 1 is x plus 1 times x plus 1. That minus 1 just comes along for the ride. And then you can see I get my perfect square. All right, so x plus 1 squared minus 1. All right. Okay, so just like before, I could check my factoring. Let's check that I did this correctly. So if I do x plus 1 squared minus 1, I'll do my perfect square, which is x squared plus x plus x plus 1. So remember that x plus 1, it's right here, right? X plus 1 times x plus 1. That's how I get this. And then the minus 1's right there. So the 1 and the 1's cancel out, and the 2x's become a 2x. And you can see I get exactly what I start with. So x plus 1 squared minus 1 is the exact same thing as x squared plus 2x, right? Because I added 0. I change the way it looks, but I do not change the expression when I add 0. All right? Okay. So now let's get a coefficient. So what if I had 2x squared plus 4x? Well, let's see if our basic understanding works. So what we wanted to do with completing the square is we cut this in half. So 4 divided by 2 is 2. And then I square it. So I'll need to add and subtract a 4. All right, so that's what we did before, right? We added that 0, but a very clever 0. So now I have 2x squared plus 4x plus 4. And I need to factor that blue into a perfect square. Well, you'll notice there are no factors. This cannot be factored, the blue part, right? And even if it could be factored, right, there's a 2x squared right here. The only factors of that are 1 and 2. It would never have factored into a perfect square, right? So even if it were possible to factor this, it will never be a perfect square. And I want it to be a perfect square. All right. So clearly, if there's a coefficient out front, if there's a number in front of the x squared that isn't 1, our little trick or our little technique of dividing it by 2 and squaring isn't going to work. All right. So the question is, what will work? Well, here's what we do. So if I have 2x squared plus 4x, notice they both have a common 2. And in fact, it doesn't even matter. what I need is this x squared to have a 1 in front. So I need this 2 to not be here. So whatever this term is, that's what I'm going to factor out. So I'm going to pull out a 2. Okay, and now how did I do this? I pulled out a 2 and then I divided each piece by 2. So 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. So I just did my normal factoring. Right? And factoring is about division. So I'll divide each piece by what I factored out. Okay? Now I have an x squared plus 2x. I have exactly what I can complete the square of. So now I'll cut this in half and do my add 1, subtract 1. Right? Now this is a perfect square. So I'll take that blue and make it x plus 1 times x plus 1. And the minus 1 still just comes along from the right, just like it did before. The only difference is now there's 2 times all of what I'm doing right now. So I'll get 2 times x plus 1 squared minus 1. And now at the very end, I'll just distribute that 2 back through. So 2 times x squared plus 1, or x plus 1 squared is just 2 times x plus 1 squared. And 2 times negative 1 is negative 2. Okay, so I was able to complete the square only after I factored out that leading coefficient. Okay, and that's the trick. And that's the technique here. Well, I suggested that 2x squared plus 4x is the same thing as 2 times x plus 1 squared minus 2, so let's check it. Let's do our distribution. So I'm going to have a 2 times x plus 1 squared minus 2. X plus 1 squared is x squared plus x plus 1, right? So you just do x plus 1 times x plus 1, and then the minus 2 comes along, and now I'll distribute the 2 through, and I'll get a 2 times 4, or 2x squared times 4x plus 2, and then there's still that minus 2, and you see those cancel, so this does equal 2x squared plus 4x. So in whatever my context is, if I'm given 2x squared plus 4x, I can use that, or I can use this equivalent expression, which is 2 times x plus 1 squared minus 2, right, which is a perfect square. So I can use either one. All right? Okay, let's try an example. Let's complete the square on 5x squared plus 30x. So there's a leading coefficient that isn't 1, so I'm going to have to factor out that 5. So again, you always want to take out whatever number's in front of x squared. And how do I do it? By factoring, I pull out the number I want, then I divide each piece by 5. So I get x squared, and 30 divided by 5 is 6, so 6x. And now I just do completing the square on the blue. So half of 6 is 3, so 3 squared is 9. So I'm going to add a 9, subtract a 9. I know that x squared plus 6x plus 9 is a perfect square, and it's going to be x plus 3 times x plus 3. I'll make that my perfect square, and then I'll just distribute the 5 back through. So it'll be 5 times x plus 3 squared minus 5 times 9 is 45. All right, so I just completed the square on 5x squared plus 30x. All right, okay. So I'm suggesting that these two are equivalent. So again, let's go through our check. Let's check it. So I should be able to do distribution to figure it out. So x plus 3 squared will be x squared plus 3x plus 3x plus 3 squared is 9. So I'll multiply 3 by 5 to do the distribution. You'll get 5. Well, I actually put the 3 x's together to make a 6x, and now multiply 3 by 5, and you'll get 5x squared plus 30x plus 45. You'll see the 45's cancel out. So this is indeed 5x squared plus 30x. All right. So we just showed that we completed the square, correctly. So 5x squared plus 30x is the exact same thing as 5 times x plus 3 squared minus 45. They're equivalent. So depending on my situation, I could use either one. All right. Okay. All right. So you want to pause the classwork and pause the video, and you want to do classwork problems 12 or 10 and 12. All right. Okay. Let's just do one more example, and then we'll be good. I want to complete the square on this now. I have 3x squared plus 24x, and now I have another term here. Okay, now remember, from completing the square, all I need is an x squared, a squared, and an x. I don't care anything about this negative 3, or this minus 3, right? So I'll just keep it along for the ride. But I do care that there's a 3 in front of the x squared. So what I'm going to do is factor out that 3. But I'm only going to factor it out of the x squared and the 24x. Because those are the only two pieces I need to complete the square. So why bother with the minus 3? I'll just carry it along for the ride. All right. Okay, now we do our completing the square. Take half of 8, which is 4, and squared is 16. So in order to get a perfect square, I'll need to add a 16 and subtract a 16, right? So again, we add that clever 0. Now I know that the blue is just a perfect square, x plus 4 times x plus 4. I'll write that as a perfect square. And just like before, now I'll distribute the 3. So I'll get 3 times x plus 4 squared, and then 3 times 16 is 48, so I'll get a negative 48. And now here's where the minus 3 comes into play. So now I can combine these last two terms. So this really is 3 times x plus 4 squared minus 54. All right? Okay, so like before, I'm suggesting that these two are equivalent. So let's run a check. Let's check and let's use distribution. So x plus 4 squared will be x squared plus 4x plus 4x plus 16, right? And the 16 is just this 4 squared. All right, so now I'll distribute actually I'm gonna collect my like terms again. So my two 4x's, I'll make an 8x. All right, distribute to 3. So I'll get a 3x squared plus 24x plus, again, 3 times 16 is 48. And now I have two constants, like terms, now I can combine these. Right, so 48 minus 51 is minus 3. So you'll see that 3x squared plus 24x minus 3 is the exact same thing as 3 times x plus 4 squared minus 51. All right, and again, depends on our situation. I might want to use either one. But it's nice to know that I have a technique where I can get this in a different form. Okay, all right. Okay, so you want to do complete class for problems 15 and 18. Right, it's actually the end of the video, so you just stop here and do those two problems.